All right, today we're going to be looking at section 3.5. This is derivatives of trig functions. So in the beginning, we kind of give you some trig limit definitions. Usually when we take the limit, we would just do direct substitution, but if you kind of go through and read, it's letting you know that you cannot do the limit by direct substitution because as x goes to 0, both the numerator and denominator go to 0, and so you get an indeterminate form, and you kind of see that with the graph. And so this kind of goes through explaining and giving proof of the limits that we're going to be using and manipulating throughout my math lab to prove true trig identities. And so just here's an example that you can kind of walk through. This one is not in the exact form because we have sine x divided by x is 1, and this is sine of 4x. So we need to do some algebraic properties to kind of get it to be the same. And so what they do is multiply by 4 on top and bottom, and then you'll get something of a similar form, and then they substitute or do a change of variable, and then we can evaluate the trig identity. In the same form, you can divide by x in this second example, and then use the identities that we're given to solve. Then we kind of get to see the proof of why those derivatives are what they are, and then we get a general form, just a memorization. The derivative of sine is equal to cosine. The derivative of cosine is negative sine. So when you take the derivative of cosine, the sign changes. The sign remains the same when you take the derivative of sine. And then you get to see some examples here using some of the same properties we've done before. Product rule, adding different functions. You can see the quotient rule. So you can see the derivative of tangent, they go through the proof. And then here we give you the derivative of all 6 trig functions. So it'd be good to just kind of refer back to the table that you guys are given in class, or just this list. And then the more you use them, you'll begin to commit them to memory. So you don't have to go through and do the proof every single time. Some of them you just kind of get based on the derivative. And then you get to see a few more examples. And then we start talking about higher order derivatives. So when you see the dy dx, that's the first derivative. If you see a d squared dx squared, that's the second. And then a third, this third derivative, a fourth derivative, and so on. And then that will pretty much wrap up what we're going to be looking at today. So we're going to jump into my math lab and do a few examples.